let's do a cosmology segment. And this one's going to be pretty short and pretty sweet. First, let's thank the true stars of this production, our patrons. Please consider becoming a patron at patreon.com/smAshomash. Thanks to our patrons, we put their names in lights. And by the way, in April, we'll be doing a contest to give somebody a free month at the lowest tier in Patreon. Again, patreon.com/smAshomash. And let's talk about some magnetic fields. So, our viewers may be very familiar with M87, the quote, black hole, end quote. And what we're looking at here is polarized light emanating from the torus, which surrounds the massive radio source at the core of galaxy M87. Why? Because polarized light gives us insight into the potential field surface source lines, the magnetic field lines coming from the massive radio source at the core of M87. And you can see the way that these protrude out of the central region. Probably no real surprise there. If you want to read more about it, have a look at this article. This one's from SciTech Daily, although it'll be all over the Science Wire. The magnetic fields at the edge of M87's massive radio source. I try to not refer to black holes as black holes, folks, because since the mid-90s, I noticed that some folks, enlightened astronomers, were referring to, quote, black holes, end quote, as massive radio sources. And you can see some insight into the magnetic field lines in the jet of M87. Very interesting. And we use polarized light and radio interferometry. To get this, it takes quite a lot of work. Thanks to everybody who contributed to this data set. Fascinating insights into the magnetic field force lines of the jet. So a fantastic piece of data here for all of you interested in cosmology out there. The potential field surface source lines, the magnetic field force lines of the jet at galaxy M87 and the massive radio source located at its core. Let's pick a random number using our quantum random number generator here between 1 and 1031 to pick a quote random end quote object at the Neil Gorell Swift-Bat X-ray Observatory. This one's easy to remember. It's number 999. And if you go to the Neil Gorell Swift-Bat X-ray Transient Monitor, BAT stands for Burst Alert Telescope, and you scroll all the way down toward the bottom of the list here, you'll find number 999 is galaxy NGC 7213, a Serfert 1.5. And allow me to correct myself. I said something wrong about BL Lacertae objects. BL Lacertae objects are not flat spectrum quasars. BL Lacertae objects are specific spectral emitters, not flat spectrum radio quasars. I got those mixed up. I apologize. BL Lacertae objects, again, different than flat spectrum radio quasars. Flat spectrum radio quasars produce a full spectrum of electromagnetic radiation. BL Lacertae objects have specific spikes in their emission spectra. So here are the emission spectra from galaxy NGC 7213. And it's a Serfert 1.5, which is a type of active galactic nucleus. And it all has to do with our perspective. A Serfert 1.5 galaxy, folks, is a galaxy where we're not looking quite directly perpendicular to the galactic plane. So here's the let's say here's the jet field. A Serfert 1.5 galaxy would be looking at it sort of from this angle, where it looks kind of bright, but not blazar bright, as if you were looking from this angle. Does that make sense? I hope that makes sense. Anyway, let's take a visual of NGC 7213. You can see it's a fairly variable X-ray source. Here's the 30-day chart of its X-ray transient outbursts. And just give it a minute to load here. We'll bring up Aladdin Light, and we'll show you a couple wavelengths. So this one actually looks like an ellipsoid galaxy. We don't see any sort of indication of spiral arms here, maybe a little bit. I see a slight indication of a dust lane right in this area. And let's take a look on the 2MASS, which may give us some additional insight. There's the 2MASS, which is infrared light. Let's take a look at pan-stars, which is a series of optical bands, and it's not on pan-stars. How about in blue light? May give us some additional insight. And we do see some spiral features here. You can see this dust lane as well as a dust lane right there. So some indication of some spiral arm patterns. How about on Chandra? And there it is on the XMM multi-mirror project. It's Galaxy NGC 7213, folks. Today's featured quote random and quote object in today's Cosmology segment. And if you enjoy the Cosmology segments, don't forget to press like and subscribe on YouTube. And let's get back to some electronic sort of data. Yes, electronic data, folks.